In this tutorial we are going to look at trigonometry and in particular angles of elevation and depression. An angle of elevation occurs when you look along a horizontal line and then look up. The angle between the horizontal line and the angle at which you are looking up is the angle of elevation. In this example we are looking up to the top of the lamppost, thereby creating an angle of elevation. In this example the observer from the hot air balloon is looking along the horizon and then down towards a landing zone. The angle formed between the horizontal line and the line of looking downward is the angle of depression. We are now going to examine how trigonometry can be used along with the angle of elevation to calculate the size of the lamp, and how trigonometry can be used along with the angle of depression to calculate how far the balloon has to drop to reach the landing zone. In this example the observer is 15 meters from the lamppost and looking up at an angle of elevation of 40 degrees. And we can use ratios of trigonometry to calculate the size of the lamppost. We are given the size of an angle and the length of one side. The side facing the angle is always the opposite, and the side touching the angle is always the adjacent. Therefore we are looking for a trigonomic ratio that consists of an opposite and adjacent, and this ratio is the tan. So using tan of the angle 40 equals the opposite over the adjacent, we can transpose the variables in the formula to give it in terms of the opposite. The opposite equals the tan of 40 degrees multiplied by 15, and this is equivalent to 0.84 multiplied by 15, or 12.58. Therefore, using the tan ratio, we have calculated the size of the lamp at 12.58 meters. However, we have been asked to give our answer to three significant figures, so our final answer will be 12.6 meters. In this example we have to calculate how far the balloon has to drop over a distance of 1000 meters to reach a landing zone. The angle of depression is the angle between the horizontal line and the angle at which the observer is looking down, and this is given as 30 degrees. The side facing this angle is called the opposite side, and the side touching this angle is called the adjacent side. And again we have to select which trigonomic ratio consists of the opposite and the adjacent, and again this ratio is the tan. So the tan of the angle is equal to the opposite divided by the adjacent. But we are looking for a value for the opposite side, so we have to express our formula in terms of the opposite side, which means we have to transpose the variables. The opposite is equal to the tan of 30 multiplied by 1000, which is 0.58 multiplied by 1000, which is 577.35 meters. However, in this question we have been asked to give our answer to three significant figures, so our final answer is 577 meters. Remember, ratios can be used to calculate angles or the length of sides. And if we remember our key term, SOHCAHTOA, we can also remember the relationship between the three ratios in terms of angles. And for each ratio, if we want to find the length of a side, we simply transpose the variables in the formula.